Good. All right. All right. Well, it's wonderful to see this interaction and this collegiality, and hopefully it will spawn even a larger number of projects as Scheme 2 did. Scheme 2, we ended up coming forth with 7 research ideas that ended up getting some type of funding and moving forward. So hopefully today will be more. As you'll see, some of the clinical faculty will be coming in and out throughout the day. But it's my great pleasure to introduce Dr. David Harry and Dr. Ben Yu. Obviously, those of us in CITRIS are very familiar with Dr. Yu, who is the Director of CITRIS UC Davis and a Professor of Electrical Engineering. But first on is Dr. David Harry, who has been with the health system for quite a few years. I won't go into the exact number, Dr. Harry, who has held just a variety of roles within this medical center. But probably one of my favorite roles that Dr. Harry has had was Chief HIPAA Compliance Officer. So I would like to offer up Dr. Harry's knowledge and resources. If you have any HIPAA questions, please don't hesitate to ping Dr. Harry, because he is incredibly knowledgeable about that. But his current role is as the technical architect for the California Telehealth Network. David's current title is Director of Technical Operations, but really has been in the forefront of designing the CTN. And we really appreciate him taking time out to talk to us about the research opportunities, because as Dr. Nesbitt continues to say, that CITRIS has been and will continue to be the research arm of CTN. And with that said, Dr. David Harry.
Thank you, Dr. Siddiqui. Well, Dr. Siddiqui very diplomatically didn't mention how long I've been here. I will say, though, that I installed the first local area network at UC Davis Health System, in those days UC Davis Medical Center. So that will help, I suppose, date me. I'm very pleased to be here today. I think this is in a very, how shall I say, epiphanal time for the California Telehealth Network. A number of you I know were present at the recent launch event. And we have recently begun active construction of the network. We have 2 sites that have been connected, and over the next year or so that number will grow very substantially. And it's really going to, it's really made me stop and think about some of the tremendous research opportunities that are going to be available within the California Telehealth Network. And what I'm attempting to do today, first of all, I'm going to very blatantly evangelize just a little bit about some of my own personal prejudices about some of the work that needs to be done. And then start by really saying that this building, this medical center, and the Innovation Center are very appropriate models for what we ultimately would like to see in healthcare in general. This bastion of academic and clinical excellence is obviously could serve as a tremendous model, and if that were available everywhere, then a lot of the healthcare problems that we're confronting today simply wouldn't exist. But the reality is that you don't have to go very far out of the city limits of Sacramento to find a very different world of healthcare. And one of the overarching observations that I'd like to make here at the start of my talk, and I'll be talking about specific aspects of it, is that we tend to, as researchers living in an environment like this, take a lot of infrastructure for granted. Having a 100 megabit per second connection to our laptop, having a 10 gigabit per second connection to a scenic backbone that provides unparalleled access to world technologies. Those technologies are very rare and hard to come by in the rural environment. And so as we've been working on the development of the California Telehealth Network and now building it out, it has really been a matter of great interest and concern to me about the lack of availability of network infrastructure in rural sites. And you heard Dr. Jonah Froelich's talk, you've heard Dr. Siddiqui talk about some of the tremendous technologies that are coming down line. but none of those technologies will be applicable to rural sites unless we have the correct network infrastructure. And so what I'm really going to talk about today is some of the realities of developing network infrastructure, primarily in rural areas. And I do want to leave you, and I'll say it in advance, and I want to leave you with one very distinct paradigm, if you will, that don't take infrastructure for granted. When you're looking at developing technologies, be they clinical, be they imaging, be whatever, please bear in mind that the infrastructure that's available to support those technologies in rural, unserved, and underserved areas has to be, quote, appropriate technology. And I'll talk a little bit about some of the limitations. And also, most importantly, I'm going to talk about some of the fertile areas for research that I know are actually underway in CITRIS, and would encourage those of you who are working in these areas of infrastructure, particularly in wireless, to really look at developing projects around specific sites within the California Telehealth Network. I always like to begin with a quotation by Dr. Tom Nesbitt, actually, and it applies very, very specifically to what we're talking about today. One of the problems is that we are applying new technology to a broken model of healthcare instead of using technology to facilitate a change in the model of care. And I'm sure a number of you have heard him speak very eloquently about that, how we can use networks like the California Telehealth Network and the advent of technology to drive a more efficient model for healthcare. But part of that, as a corollary, is that nowhere is that technology challenge greater than in rural, unserved, and underserved areas. So unless we're able to provide the network technology for the rural, unserved, and underserved areas, we're going to leave those folks behind as we currently are. Just to put a scope and scale on the problem that we face, obviously there's a large number, many, many millions of Californians are currently uninsured. And one of the most compelling issues is the shortage of healthcare professionals, not only in California but nationally. We have a highly rural state, and I was very shocked to hear a recent demographic analysis of physicians that practice in rural areas. Something like 60% of physicians that practice in rural areas are close to or over the age of 60. So we have a compelling, the current shortage of healthcare professionals is going to become a huge, compelling, and almost intractable issue, because we simply we cannot train, we cannot motivate enough physicians to move to rural areas to practice. We have to compensate by using such technologies as telemedicine and telehealth. Telemedicine can obviously serve as an effective means to bridge healthcare disparities in rural, unserved, and underserved areas. And even more specifically than that, Jonah Froelich talked very decisively about the needs to develop health infrastructure to support HIE. And obviously, in order to have that kind of interoperability, we have to develop a sufficient network technology out to these rural providers if they're ever going to have an opportunity to take advantage of that. Am I set?
It'll be just a second.
Okay. So, broadband accessibility in a suitable, with suitable technology is going to be an absolute requirement in rural areas. And really the rest of my talk over the next 15 minutes or so is going to be discussing what some of the real realities are out there and what are the potential solutions that could be brought to bear, and how CITRIS research activities could advantage that. Well, if you look at the landscape of broadband availability and broadband adoption within healthcare professionals now, rural areas are sadly deficient. Okay, there's a lack of technical expertise in design, installation, and support. Very, very few rural clinics and physicians are using telemedicine, for example, or other telehealth services, and a lot of that is simply due to unfamiliarity or unavailability. And then obviously one of the principal issues is the variable reliability and quality of connections. Well, the government is not completely oblivious to this problem, and for many years there's been a universal services support program under the Federal Communications Commission. We all see a few pennies of our money subtracted from the bills, from our telephone bills. All that money in aggregate, believe it or not, totals about $8 billion a year, most of which goes to telecommunications providers to provide services in inherently high-cost areas like Hawaii and Alaska. But an amount of approximately $400 million a year is specifically allocated to provide subsidies for network connections for rural health care providers. The unfortunate reality of that program over the last 5 or 6 years is that only a very small percentage, roughly 10% of that $400 million, was actually applied for. And it had to do really with the fact that it was a typical government program. You fill out 25 forms, wait a month, fill another 25, so on and so forth. So I'm really very pleased and proud to say that UC Davis Health System was one of the universities and organizations that was consulted by the FCC to find out what was wrong with their existing program, and so out of that consultation and number of others around the United States, the Rural Healthcare Pilot Program was created, and it turned out that a large percentage of the $400 million was actually allocated to this program. There were something like 81 awards made nationally. Our program, the California Telehealth Network, received the second largest award and the largest single state award. Pays 85% of the telecommunications related charges, and really is intended to provide heavily subsidized access for healthcare providers. So just very quickly, the California network, our timeline, and we formed a consortium including the governor's office. It's really a blue ribbon panel of state organizations, nonprofit healthcare funders. We submitted a single proposal on behalf of the state of California in mid-2007. University of California is the managing partner of that consortium. We're actually putting the nuts and bolts and the bits and bytes together to make it work. We were awarded $22.1 million, which I said is the largest single state award. And we had a number of very, very gracious other awards made and contributions by the California Emerging Technology Fund, United Healthcare Pacific Care, and the NSHE nonprofit corporation have also contributed money to us. Here's our rough timeline. 2008, roughly between 2008 and mid-2009, we recruited over 1,000 different clinical entities throughout the state of California, and you'll see the distribution here in a minute. We have now completed an RFP process, and we made an award to AT&T, who will be providing an extensive amount of the network services that we're going to be using. And we, true to form now, we've begun construction in Q3 of 2010. And we estimate that once the backbone is fully built and configured, that the actual build-out will take somewhere between 12 and 18 months. So we're really just on the cusp of very, very active construction and outreach into rural areas. And again, the very, I think, very gratifying launch event took place in August of 2010. This is a map that shows the distribution of the sites, and you can see we literally have sites reaching from the northernmost extent of California down to the border with Mexico. What this particular display doesn't show is that a very large percentage, almost 50% of these sites are in what are federally designated rural areas. And that is not only a huge benefit to us, and we're very gratified by that, but also brings to the table a number of very, very substantial technical challenges to provide service to these people. And we also made a special effort to recruit tribal areas, and so the little sort of Fs, or those little symbols, show the distribution of tribal sites that are going to be part of the California Telehealth Network. And again, as you can see, they're really distributed broadly throughout the state. Well, I'm not going to labor on this too long, but as precise, just very quickly touch on some of the important technical highlights. This will, of course, be an IP-based network. A dedicated end-to-end, no internet interconnectivity. That was one of our very, very strong architectural design points because we wanted to provide HIPAA-compliant security and also provide a very defined level of quality of service throughout the state. And then all of the various support criteria to make it a healthcare medical grade network, including 24/7 monitoring. And then we will also be peering with Scenic to provide access to Internet 2, National Lambda Rail, and Internet and the public Internet. This is, in very broad form, sort of a 30,000-foot view of what the architecture is. The backbone of the network will really ride as a virtual private network on the AT&T statewide backbone. It will be an MPLS routed network, and those of you who are familiar with networking terminology know this is one of the newer, quote, state-of-the-art routing protocols. We specifically selected that for one very important reason. In addition to providing more efficient, arguably more efficient routing technology and performance, it provides a so-called any-to-any VPN technology. Because it's a medical grade network, it is extremely important that it be a private network. And one of the nice features of an any-to-any VPN is simply by connecting an individual site up to the network, they become part of a secure virtual private network cloud. So it doesn't really matter with whom they communicate within that cloud. The communications are all completely secure, and that provides for a medical grade network. There are two very important features of this network, and I'll really focus on the rest of that. This backbone, of course, is a multi-gigabit backbone, so performance on that network is not necessarily the major issue. Where the name of the game is, where the rubber meets the road, so to speak, is that connection out to the individual customer sites. And that is going to be the bandwidth limitation that we will have to most of our rural sites. And you will notice that it's labeled typical site 1.5 to 10 megabit per second. If you look at the infrastructure available, primarily in those rural sites, and I'll talk about why this is true in a moment, the 1.5 megabit per second is probably going to be the maximum bandwidth we can deliver to most of the rural sites. So very briefly, what I'm going to talk about now is the physical infrastructure limitations out there that provide that bandwidth limitation. I want to talk about how we can deliver quality of service and why quality of service is such an important criteria in a bandwidth-constrained environment. And then also I want to talk a little bit about the need for technical support. And I thought I'd sort of organize this in terms of an OSI model. We'll look at the physical infrastructure needs in rural areas, look at some of the current limitations in wireless applicability at OSI level 2. And really what I want to emphasize there is that in order to provide medical grade quality of service that we need in rural areas, we really need to look at providing explicit quality of service within the capabilities of wireless, something that really doesn't exist today. And then, of course, explicit quality of service at the router level. I'll talk a little bit about that. And then, most importantly, and sort of setting up as a straight man for Dr. Ben Yu, we're going to talk about application-aware quality of service. And what that is and how important that can be to serve rural participants. Well, first of all, the gold standard. If you walk around this campus, literally every building is served by single-mode fiber that has tremendous, virtually unlimited bandwidth capability. Well, the reality of things is that there is a critical shortage of fiber availability in rural areas. And that really drives everything. So what we need to do, first of all, at the OSI level 1 is look at innovative solutions for installing fiber infrastructure where it's badly needed. And I want to give real credit here to Rochelle Chong, who is a former commissioner on the Public Utilities Commission, who's been working very closely with our Caltrans in order to provide facilitated project planning and approval to get fiber out to these badly needed areas. And I saw a demonstration a couple of weeks ago that I was very impressed with, and I'm going to show you a couple slides. But the bottom line is, if we're looking at research opportunity, the biggest possible bang for the buck, anything that will improve the ability to install fiber infrastructure or will improve the performance of fiber infrastructure where it's currently available is a tremendously important area for rural environment. Because here's the reality. Virtually all the rural sites, aside from some regional hospitals, are served by copper wire. And those of you who are familiar with the technology know that the limitation to fully synchronous bidirectional communication on copper is the T1 circuit, basically 1.5 megabit per second. So we're confronted with two realities. Number one, we have a very limited physical infrastructure that's serving most of these rural facilities. And yet we have a bandwidth need that surely eventually, if not now, is going to exceed that 1.5 megabit per second threshold. So as I said here, the other limitation, I wish I had brought up the map showing rurality, but some of the spans that we are going to be running from a central office to these rural sites, you'll note that some of them are up to 250-mile spans for a T1. So low-cost, highly cost-effective infrastructure that can support very long infrastructure runs is going to be a very important technology. Now, there's a little bit of an irony here. The federal government is not unaware of this. The FCC is not unaware of this. And they very graciously and very generously have put these healthcare-specific programs together. But here's the irony. Those of us in this business, or those of us who just think about it for a minute, understand that in order to put discrete infrastructure into a single clinic, especially when they're very, very, very broadly distributed, is going to be extraordinarily expensive. So the smart way to do business would be to do it on a community-based way. That is to say, if you're going to put fiber in, you don't just run a fiber strand to a clinic. You run it down the entire street so that the banks and the pharmacies and so forth. Unfortunately, the programs that we are funded by are healthcare specific. So we have to look at alternative technologies. If we can't afford in a cost-effective way to provide fiber where we really need it, then we need to look at additional technologies, and wireless really is going to be the answer. I just want to show you some pictures of this very innovative technology that is now just now coming to the fore to install fiber. This machine cuts a very, very narrow trench. This is called micro-trenching. Cuts a very, very narrow trench in the pavement. And then if you can look at the far right, you'll see that little pigtail, that white pigtail sticking up the cone. That's actually a fiber tube, a hollow fiber tube. And then they come along behind that and put a special grout material in the slot. It dries in about 8 hours. And then that's the grout in there. And then they come back and put asphalt over the top of that. So it's possible using this kind of technology to put about 4,000 feet of fiber in the ground every 2 days. So we're very, very hopeful that Caltrans will permit this to be done in this, on California roadways. And another interesting thing is we really are using infrastructure that was placed in the ground and put in on the telephone poles many, many years ago, before environmental studies were required and before very, very extensive permitting requirements were recovered. So one of the few places you can actually dig and put trenches without getting extensive environmental approvals by the state is in the Caltrans roadways. They are exempt from environmental and other permitting processes. So we're very hopeful this happens. But it's going to be a longer-term technology, and it's only going to come on a community-wide basis, not to serve individual clinics. So what do we need to do to serve those individual clinics? Well, obviously, wireless technologies are one answer. And I'm going to wrap up here in about 5 minutes and get to the punchline so that Ben can tell us how it's going to work. One of the problems is that we have to span very long distances, and money is very limited. So CITRIS, as you know, has some very, very exciting and innovative work on low-cost, long-distance, point-to-point wireless. That is a technology, I believe, that will have very, very important impact on the California telehealth network, as we need to inch our bandwidth needs up beyond the 1.5 megabit per second connection that we're going to initially give our rural providers. So, you know, we really have two ways to deal with congestion management, and I'll show you how we're doing it now. And what I propose would be a very, very important research activity for CNIC to take on. Obviously there's the big pipe approach, and that's what we use in our backbone technologies like CNIC and Internet 2, where you have fiber availability and can basically put so much bandwidth on the fiber that we really don't have to worry about congestion too much. And then we deal with the last mile, and in the rural environment, the very problematic last mile, where bandwidth is highly constrained, and we have to use that bandwidth in a very intelligent way, and that's why we need so-called delineated quality of service. Well, obviously, if you have a freeway, you don't have to worry so much about congestion. What we need is the equivalent of an ambulance that tags our individual IP frames and allows high-priority traffic to flow when low-priority traffic is also present. And I'm going to skip over this because I know Ben's going to cover some of that. So what we are using on the California Telehealth Network currently, because we have this constrained bandwidth into our sites, is a specific quality of service designation called MPLS class of service. And we'll be providing two classes of service, one of which will be reserved for telemedicine and one will be reserved for others, real-time critical patient care activities. And what happens basically is that traffic is specifically tagged, and as it flows through the network, it gets a higher priority. So it's a way of using the bandwidth that we have, the very limited bandwidth, in a very, very cost-effective way, and prioritizing the traffic as it needs to be prioritized. I'm going to skip this as well, because I want to finish with this overarching concept that I started with. Frugality is the virtue, okay? When we get out into these rural sites and working in an environment like this, it's very easy to take all this wonderful infrastructure for granted. But that is not available out there. And so when we look at technologies that are going to advantage these highly rural areas, efficiency, cost effectiveness, and simplicity are going to be the overarching design criteria. And one area specifically that I think would so advantage our rural providers is that technology that's right here today in our Center for Virtual Care. These highly instrumented mannequins that are used to train our physicians and our other healthcare professionals. This technology could be a tremendous advantage to rural providers. The problem being, and I've talked to most of the major vendors who provide telepresence equipment, they're very, very bandwidth hungry. And so I think a very interesting technology in an area of fruitful research activity for CITRIS would be developing appropriate immersion telepresence, not necessarily at a 1.5 megabit per second level, but really understanding that bandwidth constraints will ultimately always be the case in rural areas for many years to come, and to develop that network technology that will allow us to use this kind of tremendous training and other clinical modalities by using a cost-effective telepresence and telemonitoring. And I'm going to stop now because I want to say that one of the other issues that we face in the rural areas is lack of technical expertise. And so those of us familiar with the OSI model, just bear one thing in mind. If you're going to apply, if you're going to, for example, security or quality of service, the further down the OSI model you can push it to make it work, the better, because that means the less technology, the less technical support is needed at the end. And one of the areas that would seem so obvious would be, well, we have a telemedicine unit, and we can apply explicit quality of service on that telemedicine unit. The problem being is that the technician that's needed to install it, manage it, monitoring is not there at most of the sites. So application level, application aware technologies will become extremely important, either through deep packet inspection or some other modality, the ability for the router or the communications device to eavesdrop on what's going on and say, aha, this is a critical medical activity. I need to tag those frames and negotiate with the end site for security and make sure that the thing is operating in a medical grade way. And if you think about that, there would be tremendous, I think, research opportunities for CITRIS to get involved in those. And with that, I'm going to turn it over to Dr. Ben Yu, who's going to tell us how we can do it.